You have 250 meters of fencing. Find the maximum possible rectangular area. So we're going to draw a rectangle here. And we like to label the sideways distance. We'll call it x, the length here. We'll call this x. We'll call this y. We'll call this y. And we're trying to maximize the area. Now what do we know here? We're not given the area, but we're given the perimeter. The perimeter, the outer edge of this fencing is 250. So 250, the perimeter, is equals to x plus x, which is 2x, and then y plus y is 2y. This is just an equation. We can divide by 2 if we want. So let's divide by 2. 125 equals x plus y. Alright, now what's the question even asking about? It's asking us to maximize the area. And what's the area of a rectangle? Area equals the bottom, x, times the height, which is y. Let's try to speak the same language. Instead of x and y, let's replace y. So from the previous formula involving perimeter, we're going to isolate for y. Y is equals to 125 minus x. We throw the x over. And we're going to substitute this back into here. So the area is equals to x times y, which is 125 minus x. We use distribution, and we get negative x squared plus 125x. And notice how this here is a quadratic. Notice the negative coefficient of x squared. We know it's going to be a sad face. But the question is, where is this vertex going to occur? Recall there's a formula for the vertex. It's x is equals to negative b over 2a. So here, the a value is equals to negative 1. The b value is equals to 125. And the c value equals 0. So let's use the vertex formula, or also known as the equation of the line of symmetry. X is equals to negative b, negative 125, over 2 times a, which is negative 1. 2 times negative 1 happens to be negative 2. 2 negatives make a positive. And the question is, what is half of 125? It's 62.5. So the x value of the coordinate of the vertex is 62.5, or you could write 125 over 2. Now the question is, what is the y value? What is that maximum area? This happens to be a area graph, and this happens to be for any given x value as we increase x to the right. So we know that the area is equals to x times 125 minus x. So the maximized area is 62.5. 62.5 multiplied by 125 minus 62.5, which is 3,906.25. So you can see that we are using Desmos here. We're plugging in this actual quadratic. And when we click on the vertex, you can see that indeed the x value is 62.5. And there is the maximum area right there, 3,906.25. All right, now it's your turn.